I'm Anil Kumar, and here is a review on rationalization. This is sometimes the very first chapter in calculus. Now, why rationalization? That is very important. And what do we understand by rationalization? That is also important to understand. So let's begin with numbers which are irrational, right? So can you tell me what are irrational numbers? You are familiar with few like pi, square root 2 and all these numbers, and they keep coming up in most of your examples. And we should know how to work with these numbers, and that is why rationalization becomes kind of important for us. Now, what are irrational numbers then, and what are rational numbers? Let's review that part also. Rational numbers are the numbers which could be written as ratio of integers, you can say, or let's say p over q, where p and q belongs to integers, and of course q is not equal to 0. So these are rational numbers. Now when it comes to decimal numbers, for example, if I have a number 2.5, I could always write this as p over q, and the way to write is like this. We could write multiply and divide by 10. So it is 2.5. I want full number here, so I'll multiply and divide by 10. It's as good as multiplying by 1, correct? So what do you get? You get 25 over 10, and now we can simplify, dividing both by 2. So when you divide both by 5, so you get 5 over 2, right? So 5 over 2 is a fraction. Since you can write this decimal as a fraction, it is a rational number, not irrational number. Well, you have also come up with numbers like 1.33 kind of thing, which we say 1.3 recurring. Now these numbers could also be written in the form of a ratio, and therefore they are rational numbers. They are not irrational. Okay, they are rational numbers. Well, irrational numbers also include rational numbers, let us say like that. But, well, these are rational numbers. Okay, how do we write them as a ratio of two integers? Well, the technique is like this. We could say let me give a solution in a different thing. That's very important solution. Let's say x is 1.3 recurring. In that case, what would be 10 times x? 10 times x will be, decimal will move one place, we get 13.3 recurring, correct? Think like this. It is 1.3333. When you multiply by 10, it is 13.3333, right? Now if I do 10x minus x, that means this minus this, then what do we have? We have 13.3 recurring minus 1.3 recurring, and that gives you 12, correct? And 10x minus x is 9x. Now we can simplify for x. Let me push the page a bit, and we say x is equals to 12 over 9, and dividing both by 3, so we get 4 over 3 as the fraction, which represents 1.33. So we could write this as 4 over 3, right? So that is a perfect number in which we have integers in numerator and denominator, right? So these are all rational numbers. However, what about square root of 2 or pi? Now if I see what is square root of 2, which is square root of 2 equals to, in decimals I get a value 1.414213562 and so on. Similarly, if I do what pi is, and I say equals to in decimal numbers, so it is 3.141592654, and it just continues. What you notice here is that there is no pattern in which we could do this kind of calculation and write it as a rational number, right? So these are irrational numbers. That is why these are called irrational numbers. So I hope the concept is clear. Now the idea here is that we would like to work with most of the time rational numbers, we'll avoid that. So how to avoid it? That is what rationalization is all about. So if you have, let us say, a number 3 over square root of 5, right? Now 3 over square root of 5, square root of 5 is a number like that, which is irrational. So what we can do here is we can multiply and divide by 1, and we could write 1 as square root 5 divided by square root 5, right? That is 1. But when you do that, what do you get? You get 3 square root 5 divided by square root 5 times square root 5 is square root of 25. Some of you may like to write like this. And next step, you will say 3 square root 5 over square root of 25 is 5. So what do we see here? So what we see here is now this is irrational, right? Irrational denominator. And here we have rational denominator. So in this process of multiplying and dividing by square root, we rationalized the denominator. So this process is called rationalization of denominator. So of course we added the irrational number on the numerator, but as far as denominator is concerned, we got rid of the irrational number from the denominator. So that is called rationalization of denominator. So this is what is rationalization. So at times you could also have examples where we may have two terms in the denominator. For example, let me just take another example now. Let's say square root 2 minus 1 divided by, let me just write any number here, plus square root of 5. Now in this particular case, the denominator has two terms and both of them are irrational. Their combination is also irrational. Now how to rationalize these in such cases? We have to multiply and divide by square root of 3 minus square root of 5. Right? Same term. And this number by which we are multiplying, they are referred to as conjugate. So these are conjugate number, right, terms. So that's called conjugate terms. Now when you multiply it, then what happens? You remember a plus b times a minus b. It is a square minus b square, right? So let me write that on the top. It will always help you to understand. So if I say a plus b times a minus b, we get a square minus b square whenever you expand. Because the term a times minus b is minus ab, b times a is plus ab, they cancel out. They add to 0. So we get a square minus b square. That means this square minus that square. So when I expand this, then in the denominator, what do I get? In the denominator, when I expand, I get square of square root 3, which is 3, and square of 5, square root 5, which is 5. So again, I remove the irrational number from the denominator. So that is again rationalization of denominator. And of course, we need to multiply the numerators also. So that will be square root of 6 when 2 times square root 3. And when you multiply this by that, you get minus square root of 10. With 1, you get minus square root of 3, and this plus square root of 5. So that is what you get in the numerator. But in the process, denominator has been rationalized. It could be written now as minus 2, right? Now that is what is rationalization all about. So you could simplify this and write minus 2 here, and then square root 6 minus square root 10 minus square root 3 plus square root 5. So you understand what we did. So this is rationalization of denominator. Now in calculus, many examples, wherever you will find radical numbers, their rationalization is a technique to simplify and get your answers. And that is why this is normally the first chapter in your book. So it's kind of pre-calculus, getting ready for calculus. But I hope with this, the concept of rationalization is clear. But you know, this number could have been the numerator, and we would have done the same thing. And in that case, we would have rationalized the numerator, correct? So that is it about rationalization. I hope you understand and appreciate its concept. So you can follow up the links here and practice rationalization, and then move on to slopes and tangents. Thank you, and all the best.